KCET 2025 aspirants, so only 15 days are left, so please let us work hard. And in today's video we are going to discuss top 30 questions from one of the very high weightage topic, that is alcohols, phenols and ethers. Okay, so let's do the questions. You practice with me, do solve the questions with me. If you have any doubt in any question, put down in the comment section, I will definitely address to it. Okay, so please solve with me, put down your answers in the comment section, be interactive in the session. So I know it is recorded, but yes, please put down your answer so that I can know how many of you are actually preparing. Okay, let's start with the first question here. A compound AC7H8O is insoluble in NaHCO3 solution but dissolves in NaOH and gives a characteristic with neutral FeCl3 solution. So when it is saying that it dissolves in NaOH and gives a characteristic with neutral FeCl3, these two hints indicate that it must be a phenol group. Okay, first of all there has to be a phenol group. Okay, now the compound, if you see, there is C7, that means there is one more carbon and basically it has to be the methyl group. Okay, so one more methyl group is attached to this phenol ring. Now when treated with bromine water, compound A forms compound B with the formula C7H5OBr3. So that means three bromines are substituted in this phenol ring, right? And if you know that bromination takes place and there are three bromines attached, then that must be at the ortho positions, at para positions, because OH is a ortho para directing group. So we can have bromine here, we can have bromine here, and we will have bromine here, right? Then remember I told you that there is C7, means one more methyl group is there, so that methyl group can be present here. Okay, so what will be the formula? You can see, so you have to find the compound A. So compound A means where you have removed the, so if this is compound A, okay, if this is compound A, then at this positions, ortho positions and para positions, you will have bromine group. So this is what methyl group, that is option number B here. Okay, option number B. Next, which is most viscous? So for viscosity, what will happen? You need more number of hydrogen bonding. Wherever there is more hydrogen bonding, it will become more viscous. So if you know glycerol has 3 OH groups, right? So that will have more hydrogen bonding, so it will be more viscous, option number C. Okay, next. Okay, so before moving to the next question, I want to inform you something about our Abhyas KCET 2025 test series. So all of you know how important is to write mock test before exams, and we need to have a very good resource for mock test, and for that we are providing you the best mock test available in the market, where you have 35 mock tests including both part test and full length tests for the subjects physics, chemistry, maths and bio. Okay, and you will not only be getting here the mock test, but we will also be providing you one-shot video solutions, one-shot video revision videos, detailed video solutions. You will also be getting here chapter-wise insights for last 5 years of previous year questions. And one very important thing is live doubt clarification class. We teachers come live after every test to clear your doubts. Okay, so these all things are available at just ₹1498, and if you take our KCET Abhyas test series and get below top 1000 rank, then you can win up to ₹1 lakh. Okay, so that is something that we can give you, and compared to that, this investment is a very small investment. Many students have already purchased it and they are much ahead of you in their preparation. So if you want to boost your preparation, register right now, purchase the test series right now. The link is there in the description section. Okay, fine. Now moving to the third question here. Among the following, the products formed by the reaction of anisole with HIR. So if you have anisole, okay, and you are reacting it with HI, so what will happen? This bond will break, you will get here OH and CH3I. So that is phenol and iodomethane, option number B. Next, the heating of phenyl methyl ether with HI produces an aromatic compound A, which on treatment with concentrated nitric acid gives B. A and B respectively are. So we have phenyl, so you have here phenyl methyl ether, right, OCH 3. Now with HI, what will happen when you provide HI? Definitely this bond will break. So first I will get phenol. Okay. So A is my aromatic compound, which is phenol, and on this if I give you concentrated nitric acid, if I treat this one with concentrated nitric acid, then what will happen? I will get OH, NO2, NO2, NO2. Right. So this compound is nothing but your picric acid. So I will get phenol and picric acid. So option number D here. Right. Next, in the Y in the below reaction is, you have to find Y here. So you have OH and then you treat it with CO2H plus. First you take NaOH. So we get here, when I get this one, it is O minus Na plus. Okay. Now when you treat it with CO2 and H plus, we get back our salicylic acid, right, OH and COOH, right, and then when you treat it with CH3CO whole 2O, you acetylate this OH group and you get this one, that is COOH and OCOCH3. Okay. Now when we get this product, this will be called as your aspirin, and it is a very important drug compound. So option number D here. Let's see now question number 6. This is a previous year question and a very important question. 8.8 gram of monohydric alcohol added to ethyl magnesium iodide in ether liberates, so here is a small error, it is 2240, okay, liberates 2240 centimeter cube of ethane at STP. The monohydric alcohol when oxidized with pyridium chlorochromate, okay, so after this there is something, it gives a carbonyl compound, okay, it gives a carbonyl compound which reacts with Tollens reagent, okay, which reacts with Tollens reagent. Okay, so this part was missing, I have added. Now see, if you know that only aldehydes can react with Tollens reagent, right, and aldehydes, if you are oxidizing with PCC, then primary alcohols will give you aldehydes, right. So obviously our this monohydric alcohol is nothing but a primary alcohol, because if it is a secondary alcohol, then with PCC you will get ketone, and then ketone will not react with Tollens reagent, right. So because it is reacting with Tollens reagent, that means it on oxidation this monohydric alcohol gave us an aldehyde, and if it is giving you an aldehyde, this monohydric alcohol must be a primary alcohol, right. So based on that I can eliminate these two options, because these are your secondary alcohols, right. Now coming to this part, so what basically happens when I have ROH and you react it with Grignard reagent, that is RMgX, okay. So what will happen here, we have minus plus, so this ROMgX is formed and RH is formed, and this RH is nothing but ethane. Okay. Now in the question we have been given with 20 to 40 centimeter cube of ethane is formed. Now if I want to calculate the number of moles of ethane, then it is given volume by molar volume. Okay, so it is 1 by 10, or I can say 0.1 moles. Okay, so number of moles of ethane is 0.1 moles. Now here what is happening, number of moles is equal to given mass by molar mass, right. Number of moles is 0.1, given mass is 8.8, molar mass is this much. So now molar mass will be equal to how much, 88 grams per mole. Okay, now we have already eliminated these two options. You have to check these two options and their masses. Now 2,2-dimethyl propane 1-OL, 2,2-dimethyl propane 1-OL, and I have 2,2-dimethyl ethane 1-OL. Okay, 1 2 3 4 1 2 3 4 5. So I have 5 carbons here and I have 4 carbons here, and the molar mass should be 88, right. So let us check for both, and here I need to have 2H. So 1 2 3 4 5, right, 12 5s are 60. Then here I have 3 3 6 3 9 10 11 12. So 60 plus 12 72. Now 72, and then oxygen is there, so total 88 gram per mole. So obviously answer is option number B here. Next, assertion. Nucleophilic substitution of chlorobenzene requires drastic condition, but chlorine of 1-chloro-2,4-dinitrobenzene is readily replaced. Due to the electron withdrawing nature of NO2 group, it develops a positive charge on the ortho and para position, making CCl bond weak. Yes, so that is the reason, you know, when we have when you have this electron withdrawing group, it decreases the electron density at ortho and para position, right, and the bond becomes weak and the breaking of the bond becomes easier. So here we have both A and B correct, and R is the explanation of A. Next, we have to find the increasing order of acidic strength. This is a very important question. You will find many questions on increasing order of acidic strength. So first one is propanol, okay, then you have 4-methyl phenol, phenol, and 3-nitrophenol, 2-nitrophenol. Okay, so now if you remember that phenols are more acidic than aliphatic alcohols, right? So definitely propanol is the one, because all other are your what I'll say aromatic alcohols. So propanol is the least one, so we have two options with 1, so I can eliminate these two. Okay, now after this, here 4-methyl phenol is there, right? That is a okay, let me first draw the structures. We have propanol, so we have propanol, okay, then we have 4-methyl phenol, 4-methyl phenol, okay, then I have plain phenol, then I have 3-nitrophenol, and then I have 2-nitrophenol. Okay, now this is 1, this is 2, this is 3, this is 4, and this is 5th. Now if you see all the compounds, definitely 1 will be the lowest, so we have these two options. Now you see 2 is the one where you have a electron donating group, right, and electron donating group always decreases the acidity. So after 1 we will have 2 here, right, and if you see now these two are having electron withdrawing groups and this is a neutral group, so after that 3 will come, and then here 4th position NO2 group is there, meta directing, so it will have only -I effect, whereas this one will have -R and -I effect, so it will stabilize more. So 5th one will be the highest one, so option number A here. Next, here you have addition of H2O to alkenes. So if you have just acidic water, if you are adding, then it follows Markovnikov's rule, so OH will be added at this position, and when you do B2H6, it follows anti-Markovnikov's rule and OH will be added at this position, right? So which option we have? Here you can see both are following anti-Markovnikov, here both are following Markovnikov, here it is anti-Markovnikov and here it is Markovnikov, so this is wrong. Here you can see here Markovnikov rule is followed, and for the next one anti-Markovnikov rule is followed, so the correct answer is option number D here. Next question is the acidic strength. Again you have to find for acetylene, benzene, ethane and methanol. So if I have acetylene, that is your ethyne group, okay, then you have benzene, then you have ethane, and then you have methanol. Okay, so definitely our alcohols are more acidic, so 4th one will be the highest one. After that you have this ethyne group, that is more alcohol, so that is more acidic, okay, and after that we have this phenol, and thirdly we have C2H6, so option number A here. Next, sodium phenoxide when heated with ethyl iodide, the compound formed is, so if you have sodium phenoxide and ethyl iodide, okay, so this one will attack on this one, so what I will get here, you will get OCH2CH3, okay, and this is your one second, ethyl iodide, and this one is reacting with this one. So here you can see we won't get phenol, anisole and benzene, you will be getting phenitol, okay, so the name of the compound, please remember, phenitol or ethoxybenzene. Next, question number 12, increasing order of acidic strength again. So we have paramethoxyphenol, the first one is OH with para-methoxy group. Then we have para-methyl phenol. Para-methyl phenol. Then we have para-nitrophenol. Okay, so these are the things. Now if you see that para-nitrophenol is highly acidic because of a electron withdrawing group, right? So 3 will be the one which is highly acidic. So we have these two options. I will eliminate. Now here OCH3 is also donating, CH3 is also donating, but this is plus R and this is plus I, right? So plus R is more dominant, then that means here the acidic strength will be least. So 1 will be least, then 2 and then 3. So option number D here. Okay. Next you have to react it with HI. So I have CH3O, CH, and then this side I have CH3 and CH3. So here SN1 mechanism, sorry, SN2 mechanism will be followed. What happens where the less hindrance will there, I minus will go there. So there, here you can see less hindrance is there, so I minus will come attack here. You will get iodomethane. Okay, so where I can get iodomethane, this one, and this one is your alcohol. Option number D here. Next you have phenol, zinc dust, and this one. So phenol and zinc dust will first give you benzene, right? When I treat it with this one, first I will get benzene, okay, and after benzene will get CH3Cl anhydrous AlCl3. So I will get this one. Okay, so that is your option number C. Next 15th, CH3 whole 3 O CH3 upon reaction with HI, which will produce methyl alcohol. Okay, so now the question here is very tricky. It is asking you that which of the following ethers on reaction with HI can give you methyl alcohol. Okay, now if you see here what will happen, because it is a tertiary group, this side carbocation will form, so here I will form and here CH3OH will form. In all other cases, if you see here SN2 mechanism is followed, so here what will happen, you will get I minus will attack on the less hindered side, so CH3I will form. Here also you can see the less hindered side SN2 mechanism, so here CH3I will form, and this side also you can see this is also SN2 mechanism, so CH3I will form. Now because here there is a tertiary group is present, SN1 mechanism is followed and I minus will go to the carbocation, so here the product you will be CH3OH you will get, bond will break here and this one will take the iodine group. So the correct answer is option number A here. Next, the best method to prepare 3-methyl butane 1-OL from 3-methyl but 1-ENE. So you want to prepare 3-methyl 3-methyl but 1-ENE to 3-methyl butane 1-OL. Okay, so I have 3-methyl butane 1-OL. Okay, so now what we can do, if I just addition of water in presence of dilute H2SO4, that will follow Markovnikov's rule and OH will be added here. Now HBr in the presence of peroxide, if I add, the option number B, if I add HBr in presence of peroxide, what will happen? Anti-Markovnikov's rule will follow, right? So here bromine will be attached, and then if you treat it with dilute NaOH, this one will be replaced with OH, right? So option number B here. Next you have to find the product here, HgOAc whole 2. So what is this? Is oxymercuration and demercuration, right? Oxymercuration and demercuration. So what basically happens here? Here actually Markovnikov rule is followed, okay, but no carbocation is formed. So that means here if you see that if I simply apply Markovnikov's rule, water will go to the carbon having less number of hydrogen. But if this would have been acidic water, you can see a tertiary carbocation was there, so there can be a rearrangement. But here there will be no rearrangement, directly Markovnikov's rule has to be followed. So OH will be attached here, H will be attached here, option number A. Okay, now the product would have been option number C if it is given direct H plus and water. If this is given, first what will happen, this bond will break, here a carbocation will form. After that rearrangement will take place, this CH3 will come here and a carbocation will form here, and here the OH will be attached. Next, the relative order of esterification of the following alcohols. So if you remember in esterification what happens, you have one ROH and you have one RCOH, right? Now here what happens, OH bond breaks and here this OH bond breaks and water is removed. Now whenever this OH bond will break, what will happen, RO minus will form. So more the stable this conjugate base, better this acidity will be there, or better this bond will break. So if you see here, you have one tertiary group here, so O minus will be highly destabilized here, the conjugate base is destabilized, so here the rate will be least. So where 3 is least, we have only one option, so that is why. And you can see the other also, here it is isopropyl and here it is ethyl, so ethyl will have more stable conjugate base, so option number B. Next, propanol and propane 2-OL can be distinguished by oxidation with KMnO4 followed by reaction with Fehling solution. So if you oxidize them with KMnO4, one propanol will form you carboxylic acid, but propane 2-OL will form ketones, right? And we cannot differentiate them again. Next, oxidation with acidic chromate followed by reaction with Fehling solution. Same thing will happen with both with KMnO4 and K2Cr27. Oxidation by heating with copper followed by reaction with Fehling solution. Yes, if you see here, if I oxidize them both with copper, right? So if I have propane 1-OL, okay, and I am giving it with copper, so I will get here aldehyde, right? And if I have propane 2-OL, then with copper I will get this one, right? Now here you can see this is an aldehyde and this is a ketone, right? Now these two can be easily distinguished by Fehling solution. Okay, now these two if can be easily distinguished, so in Fehling solution this one will show positive set and this one will show negative test, so the correct answer will be option number C. Okay. Next we have this one, that is reaction with LiAlH4 and reaction with NaBH4. So in LiAlH4 when you react, when you reduce, this one is reduced as well as the double bond is also reduced. Okay, the double bond will also be reduced, this one will also be reduced to alcohol. So if I see option number A, yes, this is reduced, CH2 and here alcohols are also formed. Now if you see NaBH4, what will happen? Only this one will be reduced, double bond is not reduced, so we will have CH2OH. Okay, so that is your option number A here. Next, 21, propane 2-OL can be converted to propane 1-OL by using the following sequence of reagents. So if you have propane 2-OL, okay, if I have propane 2-OL and it can be converted to propane 1-OL, converted to propane 2-OL is converted to propane 1-OL by using the following sequence of reagents. So first what happens, concentrated H2SO4 is used. So if I use concentrated H2SO4, I will get propene, right? After that what you have to do, you have to treat it with, yes, if you treat it with HBr and peroxide, okay. So if I treat it with HBr and peroxide, what will happen? I will get OH here, sorry, I will get Br here, right, anti-Markovnikov's rule. And after that if I treat aqueous NaOH, so Br is replaced with OH, right. So the correct answer for this question will be option number B here. Okay. Next, question number 22, the end product in the following reaction. So CH3Cl KOH, this is your Riemann-Tiemann reaction. So what I will get here? I will get OH and CHO. Now 50% KOH, that means it is a concentrated solution of KOH and the compound will undergo Cannizzaro reaction. So that means you will get one product here, the one where it is reduced, the alcohol product and the acidified product. So option number B here. Okay. Next, when wine is put in air, it becomes sour due to. So what happens, the alcohol present in the wine gets converted to acids, so that is why it becomes sour, that is option number B here. Next, vinyl carbinol is, so if you see vinyl carbinol, that is your, so you see here, you need at the vinyl position there is a carbonyl group. So vinyl means we need to have a double bond of carbon, right? So this is not there because here we have triple bond. Now you see vinyl So here what happens, the carbon which contains the double bond, that carbon is having this group, carbonyl group, so that is why option number B here. Okay, this is vinyl alcohol, right? This is also vinyl alcohol directly, but that is vinyl carbonyl, or you can say that is allylic alcohol. Okay. Next, identify Z in the following series. So you have C3H7OH and with concentrated H2SO4. So definitely you will get a propene, C3H7OH. So you can have anywhere OH 1, 2, 3, 4, 5, 6, 7, right? So anywhere you put OH, the product you will get will be propene, right? That is the X here. Now if I add bromine, what will happen? This is replaced with bromine and this is replaced with bromine. So XY I got. Now when you take excess of alcoholic KOH, right? So here we have HBr and here we have HBr. So this HBr will be removed and this HBr will be removed. So we will get a double triple bond here. So that is your option number D. Okay, clear? Next, which of the following cannot be prepared by using Williamson ether synthesis? So in Williamson ether synthesis, what we take Rx plus R dash ONA, right? And this Rx must be a primary halide, right? So this has to be a primary halide and then R dash ONA will attack here. Now if you see di-tert-butyl ether, that means it is a compound like this. Okay, so either you say both side we have tertyl group here, like tertiary groups are present. If both side tertiary group is present, that means one of the Rx has to be a tertiary group. In that case, this is not possible. So option number D. Okay. Next, which of the following cannot be prepared by Williamson ether synthesis? Okay, methoxybenzene can be prepared. Benzyl para, yes, again you can see this one, di-tertiary butyl ethane, option number D. Is the question repeated? Okay, so sorry, this question is repeated here. Okay, next question number 28 will move. An alcohol gives turbidity on reaction with concentrated HCl and ZnCl2 only on heating. So if you see that tertiary will give you immediately, secondary will give you in 5 minutes, but primary will not give you if you do not heat it. So only on heating, it is due to primary alcohols, option number A. Next, when CCl4 is boiled with KOH, the product formed is. So you can see here this one, CCl4, if you are treating it with KOH, what we will get? That is your. Let us see question number 29 here. When CCl4 is boiled with KOH, the product formed is. So you can see here CCl4, if you are treating it with COH, so here there will be first alcohols are formed and on one carbon 4 OH groups not stable. So 2 water molecules will dehydrate and you will get carbon dioxide. Last question here, in Williamson synthesis, ethoxyethane is prepared by. So if I want to prepare ethoxyethane, okay, so it is by passing ethanol over heated aluminium oxide, heating sodium ethoxide with ethyl bromide. Yes, if you heat sodium ethoxide and ethyl bromide, you will get ethoxyethane. Answer number B here. Right. So these were the top 30 questions from alcohols, phenols and ethers. I want all of you to try this question and put down your scores in the comment section out of 30 how much you are getting, and if you have any doubt in any question, please do comment down. I'll definitely address to it. Okay. All the very best students, please work hard last 15 days. Let's put our 100% in this last 15 days. Okay. That's all, and all the very best. Keep working hard and please do not forget to subscribe the channel.